I'm going to go over the fall semester final exam. All right, here we go. Once again, I'm going to do the questions on the left. I would strongly suggest after I do the one question on the left, you pause this video and try to do the question on the right. I also have Desmos already open. I would strongly suggest you have that or your graphing calculator readily available. All right, question 1 says, what is the slope of the graph y equals 10x minus 15? This equation is already in slope-intercept form, y equals mx plus b, where b is my y-intercept and m is my slope. So the slope of this one would just simply be 10, or 10 over 1. Number 2, it says a group of friends built a rocket and decided to launch it from a nearby water tower. The graph shows the height in feet of the rocket above the ground as a quadratic function of x, the time in seconds the rocket has been in the air. What is the domain of the function from the situation? Okay, remember, domain means the x values. Okay, so how far to the left and how far to the right. So this is the farthest point to the left, and it points to this x value, and that happens to be 0. Here is the farthest point to the right, and that points to the x value of 7. And they're both solid dots, so that means they are included. So I can say from 0 is less than or equal to all the x values, which are less than or equal to 7. There we go. Number 3. All right, it says find the value of x that makes the equation true. All right, I'm going to show you 2 different ways to do this, okay? First is the algebraic way to do it. So I'm going to distribute the 0.75, okay? And 0.75 times 8 is 6, but that has an x with it, so it's going to be 6x. And then 0.75 times negative 10 is negative 7.5, okay, equals 1.5. Now that I've distributed, I'm going to get rid of this minus 7.5 by adding it to both sides. Those cancel each other out. And then 7.5 plus 1.5 is 9. And then the 6x comes downstairs there. Now I'm going to get rid of that 6 by dividing both sides by 6. And then x is going to be equal to 9 divided by 6. And that's 9 divided by 6. And so 1.5 or 3/2. So I'll leave it as a decimal, 1.5, okay? Because that's a nice, that's not a nasty decimal. All right. Now, here's another way you can do it without using the algebraic method, okay? We've talked about systems of equations, okay? I'm going to solve this by turning this single equation into 2 equations. And what that means is I'm going to take this 0.75, parenthesis, 8x minus 10, and I'm going to set it equal to y. So I took the left side, I set it equal to y. I'm going to take the right side and set that equal to y. So 1.5 equals y. I can graph both of those. So I'll say y equals 0.75, parenthesis, 8x minus 10, close parenthesis. And then y equals the right side, which is simply 1.5. Okay? And they cross. I'm going to click where they're crossing. And it happens to both be 1.5 on this, but literally I care about the x value. Sometimes they usually won't be the same value, but it happens to be 1.5. That's where they cross. All right. Now let's go to number 4. It says the table shows the linear relationship between the number of tickets sold and the total cost in dollars. What is the rate of change in dollars with respect to the number of tickets sold? All right. Rate of change simply means slope. Okay. And slope is defined by this formula. y2, the second y value, minus the first y value, divided by x2, or the second x value, minus the first x value. Okay? And so I'm literally going to plug these values in. So the second y value is 24, minus the first, which is 20, divided by the second x value, which is 2, minus the first, which is 0. Okay? And I can literally just type straight up, just type that in Desmos. So what I'm going to do is to do a big fraction, I pull up the keypad and I hit the divide sign first. And I'm just going to say 24 minus 20. And underneath it, I'm going to put 2 minus 0. And it reduces to simply 2. Or 2 over 1 if I was thinking of it like rise over run. All right. So turn the page. We're going to do number 5 now. All right. It says, write the equation in slope-intercept form of a line that passes through the points 3, 11. I'm going to put x and y. I always label my points. And negative 6, comma 5. That's also x and y. All right. So slope-intercept form, I need to find the slope, and then I need to find the y-intercept. I'm going to find the slope first, okay? So once again, I'm going to write the equation out. Y2 minus y1 divided by x2 minus x1, okay? And I'm going to plug my values in. So the second y value would be 5 minus the first y value of 11. It's a lot easier since I've labeled my points as well. And then the second x value is negative 6 minus the first x value, which is 3. All right, and like I said, I can just go to Desmos. I can just hit the divide button. And then I'll say 5 minus 11 on top. Oops, not 1, 11. And then negative 6 minus 3. And I don't like that decimal. I'm going to turn that back into fraction by hitting the fraction button. So that's 2/3. All right, so that's my slope. Okay. Now, I don't know what the y-intercept is. So what I'm going to do is I'm going to use point-slope form. Point-slope form looks like this. Y minus y1 equals m parentheses x minus x1. Okay? Now, it doesn't matter which point I pick. I'm going to pick 311 because there's no negatives involved. So remember, when you plug this into point-slope form, the signs change. So if that's a positive 3, it's now going to be y minus 3. I already know what m is. I just solved for it. It's 2/3. And then x, and then if that's a positive 11, it becomes minus 11. Okay? I'm going to distribute this 2/3. Okay? And I'm running out of room, so I'm going to write it over here. Okay? So 2/3 times x is 2/3 x. And 2/3 times a negative 11. I don't know what that is off the top of my head, so I'll say 2 divided by 3, get out of the denominator, times negative 11. And I don't like that fraction, so I'm going to turn it back. Or I don't like that decimal. I'm going to turn it into a fraction, negative 22 over 3. And then I still got that y minus 3 here. Now I need to add 3 to both sides. Okay. So I'm going to take negative 20. So negative 22 divided by 3. And then I'm going to add 3 and turn that back into a fraction. And so I get y equals 2/3 x minus 13 over 3. And there we go. That is my answer. It's not always going to be a nice, pretty whole number, unfortunately. Okay? All right. Number 6. If I tried typing this into Graphing in Desmos, it would not graph. At least not in this version of Desmos that I'm using, in the same version that you guys use. I need to get y by itself. Okay? So to get y by itself, I simply need to divide by that coefficient of 3. Because the x is already on the right. So that gives me y equals negative 5/3 x plus 12 over 3. I'm going to rewrite this. Y equals negative 5/3 x plus 4, because 12 divided by 3 is 4. If you have struggled with doing the math, you can literally type it in the Desmos like 12 over 3 if you want. Okay? So now I'm going to get rid of those. I'm going to type in y equals negative 5 divided by 3 x plus 4. Okay? So I can, if you struggle with using the slope, click on your intercepts. Okay? So the y-intercept is really easy, 4. Okay? Now that x-intercept says 2.4, so that's like a little, almost 2.5. That's going to be like right there. I don't really want to do that. I want to be exact, okay? So I'm going to use the slope. So it's falling 5, and it's going right 3. So falling 5. 1, 2, 3, 4, 5. Right 3. 1, 2, 3. All right, and I can do it again. Fall 5. 1, 2, 3, 4, 5. Right 3. 1, 2, 3. There. Okay? Once you have that, you can use a straight edge. I'm going to use my ID, and you should all have your IDs on. So you should be able to use your ID too. Connect the dots. Put arrows on it. Done. All right. And if I look, I got it pretty close. About 2.4. That's a little bit less than 2.5. Sure. All right. Number 7. Once again, guys, I strongly recommend doing one problem on the left, pausing the video, and then trying another one on the right. Trying the corresponding problem on the right. All right. This one says, what is the equation of the line in slope-intercept form that crosses the x-axis at -24 and is perpendicular to the line represented by this? Okay. So, first of all, perpendicular slopes. They have, their slope is the opposite reciprocal of the other line it's perpendicular to, of its slope, I should say. So the slope from this equation is already in slope-intercept form. This equation's slope is 4, 6. Okay? So slope is 4, 6. The perpendicular slope, and that upside down t is shorthand for writing perpendicular. I don't feel like writing the word perpendicular. Would be this fraction flipped, so it's 6/4. And if that's a positive, this one has to be a negative. Okay? So that means it's going through there, and it's crossing the x-axis at -24. Okay, so that means on the x-axis, it's somewhere over here at -24. Now, what's important to know about this is, yes, the x value would be -24. And also important, though, the y value would be 0 because it's on the x-axis. Oh, I have a point, I have a slope. X, y. I'm going to use point-slope form, so which looks like this. Y minus y1 equals slope m times x minus x1. Okay? So now I got y minus 0 equals -6/4 parenthesis x, and then remember, if it's, you flip the sign, so that's going to become x plus 24. And now I'm going to distribute that -6/4. Also, y minus 0 is just y, so I'm just going to simplify that y, okay? -6/4 times x is -6/4 x. And then I'm going to just do this in Desmos, so I'm going to type in -6 divided by 4 times 24. And that's going to give me -36. And there we go. Okay. All right, and let's look at number 8. It says, what is the domain and range of the function? Okay, domain, remember, are your x values. Range are your y values. Okay, so domain goes left to right. Okay, so I'm going to just kind of draw arrows from the left point all the way down to the x-axis, and then I'll go to the right point, draw those down to the x-axis as well. So that goes all the way to the left of -6 and all the way to the right of +8. So the domain will be -6, and notice these are solid closed circles. So -6 is less than or equal to x, which is less than or equal to +8. Okay? Now my range. Okay? That goes from down to up. So this is the lowest y point, and this is the highest y point. Okay? So the lowest y point looks like +3, and it's still on that closed circle. So I'm saying less than or equal to y, which is less than or equal to all the way up to here, which is +10. And that's it. Okay? All right, I'm going to turn the page and do number 8, or number 9, excuse me. Okay. It says, a manager is purchasing gifts for her staff for the holiday party. Cups of coffee are $6 each, and gift baskets are $13 each. She wants to spend no more than $175. Write an inequality to model the situation. All right. So I don't know what the coffee or the gift baskets are. That's what I'm comparing. Okay. So I could assign them X and Y. I'll just assign them X and Y. So coffee cups came first, so I'm going to assign that to be X. Gift cards came second, so I'm going to assign those to be Y. Okay? All right, and I know these are 6, and I know these are 13, so I'll say, and then the and means plus. Okay? So I got 6X plus 13Y, and then 175. Now, if I want to spend no more than 175, that means this has to be the bigger number than what I'm spending here. Okay? So that means the old alligator is going to eat towards it. But can I spend up to 175? I can. So therefore, it can have an equal sign underneath. And there we go. All right, graph the inequality. Y is greater than or equal to negative 2x plus 3. Now, this is already in slope-intercept form. Awesome. So what I'm going to do is I'm going to graph this using the intercept, which happens to be plus positive 3. And then I'm going to use the slope of negative 2. Now, I'm going to put that over 1. That helps me visualize it. So from there, I'm going to fall 2, right 1. Fall 2, right 1. Fall 2, right 1, and so on. Okay? Once I have a few points, I'm going to take my ID or some sort of straight edge. But we all have our IDs on, right? Yeah, we totally do. Connect the dots, put arrows at the ends, and we're done. Oh, well, no, we're not. Now, I'm glad I made a mistake. I didn't think this to see if it's going to be a solid line or a dotted line. I got lucky, though, because there's a line underneath it, so it is a solid line. Okay. Now, this says y is greater than or equal to, okay? So, remember, there's a couple ways you can think about the shading, okay? If it's eating towards the y, like the old alligator, I'm going to put the y on top like you normally see it. If it's eating towards the y, that means the y is bigger, so I'm going to shade above it. Or you can think about if I take an easy point like 0, 0, and I put 0 in for x and y, that tells me 0 is greater than or equal to 3. Well, that's false. That's not true. If it's false, you shade away from it. So I'm going to shade this way. There's a couple ways to think about it. All right, number 11. All right, now on the camera, it's kind of light. On your own paper, you should hopefully be able to see it a little bit better. Now it says, what is the rate of change? So that means the slope. So if you're given a graph, you can do it a couple ways. You can literally count, or you can use the slope formula. Now, if you're going to count, do not, and I repeat, do not use this specific point, because this is not a significant point. You need to find a point that's crossing like here or here, okay? Those are significant points. If you want to use that point that they give you, you need to use the slope formula. XY, XY, okay? And that's what I'm going to do. I'm going to use the slope formula. Y2 minus Y1 divided by X2 minus X1, okay? And I'll say 1, 1, and 2, 2, okay? So Y2 is negative 1 minus Y1, which says negative 2.6. Notice I put that negative 2.6 in parentheses. Okay. X2, which is positive 5, minus X1, which is negative 3. Okay. I'm going to type that into Desmos. And I'm going to let the Desmos do the math for me. So I'm going to hit divide. Okay. And I type negative 1 minus parenthesis, negative 2.6, close parenthesis, all over 5 minus parenthesis, negative 3, close parenthesis. It's 0.2. Now, on your test answer, if I was taking a test, I can almost guarantee you it wouldn't be as a decimal. They'd give it to you as a fraction. So, 1/5. So that equals 1/5. There you go. All right. Number 12. It says, write the equation in point-slope form. Write the equation of the graph, excuse me. Okay, so first of all, I want to find the slope, okay? Now, it's not giving me any points specifically, so I'm going to pick some significant points. The y-intercept is always a good one. And let's see here. So when I say significant points, I'm looking for when this line is going through the crosshairs of the grid of the coordinate plane. Okay, so it's going through there and there. So it's falling 1, 2, 3, 4 and going right 1. So that tells me if it's falling 4 going right 1, the slope would be -4/1, which simplifies to -4. Okay, now I need to find a point. It doesn't matter which point I choose, honestly. I'm going to choose this point here. Okay, so this point goes left 1 up 2. So that point is going to be -1, 2. I was going to put x, y. Okay, so in point slope form, looks like this: y minus y sub 1 equals m parenthesis x minus x sub 1. Okay, I already know where the m is going to be. It's going to be -4. And then now, see, this says +2 for the y. So I'm going to say y minus 2. And x, and then this says -1. When I plug it in, it's going to become x plus 1. And it says point slope form. Well, there you go. There's point slope form right there. Okay. All right. I'm going to turn my page and do number 13. Okay. It says a school sells snow cones for $5 and cookies for $2 at a club fair to raise money. If they sell twice as many snow cones as cookies and made $480, how many snow cones does the school sell? Write and solve a system to find how many snow cones were sold. Okay, so I have a total money as one of my equations, okay? Total being adding, and the total money that they made is $480, okay? Now, I'm going to assign my variables. I'm going to, since these are going in order, I'm going to say X is snow cones and Y is cookies, okay? So money goes with money. So what money value goes with the X value? 5. What money value goes with the Y value? 2. Okay, so there's my first equation right there. Now, this one says they sell twice as many snow cones as cookies. Okay, well, I'm still going to put my variables above these values, or these words, so I don't get confused, okay? So all that means is twice as many. Okay, so think about it. If I have $10 and you have twice as much money as me, you would have $20. What did you do? You times it by 2, okay? So I need to say, and then this is going to be I have twice as many of these. So to get this to equal this, I need to multiply the y value by 2. So x equals 2y. All right. So there's a couple ways I can solve this. I can solve it by graphing. I can solve it by elimination. I could solve it by substitution. Because this variable x is already by itself, I'm going to solve it by substitution. I'm going to take this value of 2y and plug it in for x. So what I'm going to do is rewrite this top equation, but every time I see x, I'm going to replace it with 2y with parentheses around it. So instead of 5x, I'm going to say 5 parentheses 2y plus 2y equals 480. Distribute the 5. That's 5 times 2y is 10y. Add another 2y. It's 480. Combine like terms. That gives me 12y equals 480. Then divide both sides by 12. And I don't know off the top of my head, but Mr. Desmos does. So 480 divided by 12 is 40. So y equals 40. Okay. Now, is that what the snow cones are? No. I need to find the snow cones. Okay. So what I'm going to do is I'm literally going to plug this 40 back in for y and find x. So if x equals 2y, then x equals 2 times 40. 2 times 40 is 80. So x equals 80. And that is my answer. All right. Number 14. A system of equations is graphed on the grid. Okay. Write the equation of each system in slope-intercept form. All right. So what we got to do is we got to figure out the slope, and we got to find the y-intercept of each one. Okay. Now, I'm going to focus on this dark line here first, the darker one first. Okay. So the y-intercept, it looks like is 3, or negative 3, excuse me. Okay. And then it's going up and then over. Okay. So that means it's going, and the scale is by 1, so it's going up 1, 2, and then right 1, 2, 3, 4. So up 2, right 4. Okay. Now, up 2, right 4 can be simplified to 1 over 2. And check this. If I go up 1, right 2, I'm still on the line. Okay. So this line has a slope of 1/2, and it has a y-intercept of negative 3, and therefore the slope connects the x. That is that first line right there. Okay. Y equals 1/2 x minus 3. Okay. Now, let's find the slope of this next line. It gives me 2 points. Now, I could plug these in the slope formula. I could even count. But that triangle would be this is going to be a huge slope. So let's find another significant point from 1, 5. How about this one right here? Well, that's a lot easier. So it's falling 2 and going right 1. That tells me its slope would be negative 2. Okay? And remember, the slope is what connects the x. Oh, my pen is starting to die. All right, now I need to find the y-intercept. So if I follow this line up, it hits right here, and that's going to be 7. So I'm going to say pos 7. And there we go, because it's hitting right there. And that's 1 above 6 is 7. All right, number 15. This one says, write the equation in slope-intercept form from the table. Okay, now I could find the slope by doing change in y divided by change in x, but it's not giving me the y-intercept. Now, I could use some process of deduction to figure this out, but there's an easier way. What we're going to use is the old Desmos. Okay, so what I'm going to do is I'm going to hit add item, table. Okay, I'm going to plug my x values in. 1, 3, 5, 6. Okay, and then I'm going to plug my y values in. 16, 10, 4, 1. And if you notice, it also plots the points. Okay. Then I'm going to type this, y, then the tilde, which is shift. You hold down the shift button and the button right underneath your escape key. And then mx1. Oh, and I forgot to put the 1 by the y. So y1 tilde mx1. And then plus the letter b. Okay? It gives me a whole bunch of stuff. Really what I care about are these two values here. Because remember, m is your slope, b is your y-intercept. So my equation would be y equals negative 3x plus 19. That's it. There you go. Done. Okay. Number 16. It says the graph of linear function passes through the points 12, 0. So whenever I see points, I like to label them. And 2, 5. So also going to put xy above them as well. Which statement is true? The slope is 1/2. Okay. Well, let's find out the slope's 1/2. So I'm going to do 5 minus 0 divided by 2 minus 12. Okay. So I click the divide button first. 5 minus 0 all over 2 minus 12. And then I'm turning that into a fraction. Nope, that says negative 1/2. Not that one. Okay. The graph passes through the point negative 6, 3. Okay. Well, that's a tough one to see. So here's what I'm going to do. Is I'm going to plot those points. I'm just going to do it on a table. Okay. So I'm going to type in 12, then 0, and then I'll do 2, then 5. Okay. And I'm going to zoom out. Okay. Now, if you notice, I can see these 2 points. Okay. If I connect them, like I could use like my pen or, you know, the side of my ID and connect them with, and just kind of see. So it says the 0 of x is 12. I'm going to look at part C first because the 0 means the x-intercept. That means x-intercept. So let me see about the x-intercept because that's on the x-axis. That is 12. So that is true. So this one is true. Okay. Now, if this thing passes through 6, 3, that would be right 6, down 3. That would be like right here. Okay. So, and if I click on my point, 6, and then -3, does that even look like it's going to be on that same line? It doesn't. It's not on that same line. Unless that line, you know, bends and twists, which lines don't do. Lines are straight. So it ain't that one. Okay? And then the x-intercept of the graph is -12. Well, we just figured out it's on the x-axis at 12, right here. -12 would be all the way over here. That's not true either. Has to be C. All right. What is the x-veil? I think it's supposed to say value in the solution to the system. All right. So I'm going to move my camera down a little bit so we can get a little closer. And then, all right, what's the x value? Okay, so there's a couple ways you can do this. Since the x here is already by itself, it's kind of already set up for substitution. So what I'm going to do is every time I see the x value here, I'm going to replace it with 3y plus 6 with parentheses around it. So I'm going to rewrite this equation. 5 parentheses 3y plus 6 close parenthesis minus 15y equals 30. Okay? And then I'm just going to solve. So I'll distribute. So that gives me 15y plus 30 minus 15y equals 30. Okay? And then I can combine like terms. Well, 15y minus 15y, those cancel each other out. Okay? So I get 30 equals 30. Oh. So here we go. If you've solved by substitution or elimination and you eliminated both variables, which I did, and you're left with a constant equaling a constant, if they are the same, it's always true. That tells me it's infinite solutions. So I'm just going to draw I'm too lazy to write the word infinite, so I'll write infinite solutions. There we go. All right. Try the one on the right. All right, number 18. It says, the table shows a linear relationship between x and y. What is the rate of change with respect to x? All right, so there's a couple ways I can do it. I can use the slope formula, y2 minus y1 over x2 minus x1. Or I can type this table in, and then, which is what I'm going to do. I'm going to do this. So I'm going to type in all these values: -33, -24, -15, -6. And I'm going to type in the y values: 1, 2, 5, 8. Okay, and then I can type in y1, shift, and then hit the tilde button, mx1 plus b, and it gives me all this stuff. Now, here's my slope right here. But if I was taking a test, I guarantee you it wouldn't be in a decimal form. So I'm going to take that 0.26666, a whole bunch of sixes, and then hit this button that's the fraction. So I'm going to turn that into fraction. Oh, doesn't like that. All right, so let's try it. I don't think it's going to be 133,333 over 500,000. I don't think that's the answer. All right, so sometimes it won't work. And on this one, it doesn't look like it's going to. So what I'm going to do is I'm just going to use the old slope formula then. Okay? So I'm going to do y2, 2 minus 1, divided by negative 24 minus negative 33. Notice I put that second negative value in a fraction, and then I could just type that in. So I'm going to hit divide. I'll put 2 minus 1 all over negative 24, parenthesis, negative 33, close parenthesis. Oh, I forgot to put the minus sign. There we go. And then I don't like that. I'm going to turn that into a fraction. That equals 1 over 9. There you go. That's your answer. All right. Number 19. It says, what's the solution? So you have to solve. Okay, I'm going to show you 2 ways to solve this. There are multiple ways to solve this. Okay? And here we go. I'm going to change pens too. All right, so to solve this, I need to distribute this negative 1. So negative 1 times 4m is negative 4m. Negative 1 times 8 is minus 8. I'm going to distribute this 2. 2 times 17 is 24, I believe. 34, I believe. 2 times 17, 34. 34. And then 2 times minus m is negative 2m. Okay? When you have variables on both sides, you want to move your variables to one side and move your constants to the other. Okay? So I'm going to move the negative 4m. So I'm going to do the opposite by adding it. Okay? And then I'm going, if I'm moving my variables to the right, I'm going to move my constant to the left. So the opposite of positive 34 is going to be a minus 34. And that cancels on the right. All right, so now I'm going to rewrite it. Negative 2 plus 4 is positive 2m. Negative 8 minus 34 is negative 42. And then last step I need to do is divide both sides by 2. 2 divided by 2 is 1. Negative 42 divided by 2 is negative 21. Okay. Now, here's another way you can do it. Okay. I'm going to rewrite both sides of these equations. So but instead of saying m, I'm going to use the letter x. So I'm going to say negative parenthesis 4x plus 8 close parenthesis. And instead of equaling to this, I'm going to have that equal to y. And then I'm going to rewrite this one, 2 parenthesis 17 minus, instead of m, I'm going to use x, close parenthesis, equals y. Then I can graph these like a system. So I'll say negative parenthesis 4x plus 8, close parenthesis, equals y. Oh, it doesn't like I have to put y equals first. Sorry. There we go. All right, and then I'll do y equals 2 parenthesis, what do I got? 17 minus x, close parenthesis. All right, and then I'm going to scroll up to see where they cross. Click on where they cross. The x value is what I want, is negative 21. Oh, hey, look, I got the same value. Okay. Okay. All right, here we go. Number 20 is easy. It says, which shows y as a function of x? Okay, here's the easy way. Does the x repeat? If it does, it fails. X repeats, fails. X repeats, fails. X doesn't repeat, pass. X repeats, fails. So, it has to be C. Done. All right. Number 21. It says graph the system of equations. All right, so this version of Desmos won't be nice to you and be able to graph them as they are. So you have to get them in slope-intercept form, okay? So it literally takes 2 steps. 1 is move the x over to the right side. 2, divide everything by the y coefficient, okay? So this first one, 4x plus 5y equals 45. Well, if I move that 4x to the other side, it now becomes 5y equals 45 minus 4x. And then I'm going to divide everything by 5. So y equals 45 divided by 5 is 9. And then I'm just going to leave that as a fraction, minus 4/5 x. Okay? And then I'll do the same thing here. X minus y equals negative 20. Subtract the, so that's a positive x. When it moves over, it becomes negative y equals negative 20 minus x. And then I need to divide everything by negative 1. Okay? So that changes that into y equals positive 20 plus x. Okay? So these are in intercept slope form. Okay? So remember, the slope is the number that connects to the x. Okay? Because a lot of students will see this and think, oh, on this top one, the slope has to be 9. That's not the case. That's your y-intercept. Okay? And if I type that in Desmos, y equals 9 minus 4 divided by 5x. I'm going to hit the home button so it resets. You can see it. It crosses the y-intercept at 9. And since I already have this in Desmos, I can graph the y-intercept and I can graph the x-intercept. Now the x-intercept is 11.25. I don't really have room on my paper to do that. So I'm going to use the slope. So the slope is negative 4, so it means it's falling 4 and going right 5. So I can graph this point right here, which should be 5, 5. So 5, 5, that's easy to graph right there. Once you have 2 points, you just take a straight edge and graph it. Okay, so I'm going to take a straight edge, my ID, which you should all have your IDs on. Yes, Mr. Fee, we totally have our IDs on. All right, and then this other one says 20 plus x. Well, I don't really have a thing. Oh, wait a minute. I made a mistake. That should be minus 5. So instead of divided by negative 1, it should be negative 5. Ah, so that changes this. That's going to be y equals negative 20 divided by negative 5 is positive 4. Negative 1 divided by negative 5 is positive 1/5. That's going to be x. Okay, so I can type that one in. So y equals 4 plus 1 divided by 5 x. Oops, not cx, x. There we go. So it has a y-intercept of 4. Oh, and it's also going through 5. So cool. There you go, 4, and then I already have 5, 5 graphed. There we go. And that's where they cross, so I'm going to label their solution of 5, 5. There we go. All right, number 22. It says, a customer at a store paid $87 for 6 large candles and 4 body lotions. All right, candles I'm going to assign as X. Body lotions I'm going to assign as Y. Oh, okay, and I even did it. Okay, at the same store, a second customer paid $9 more than the first customer for 4 large candles, which are X, and 6 body lotion. Okay, so the first customer 1. So I got customer 1, and I got customer 2. Okay, customer 1, it says it's 6x and means plus 4y, totaling $87. This other one says they bought 4 large candles and 6 Y candles. Now, it does not equal 9. It needs to be 87 plus 9, which happens to be 96. Because 87 plus 9 is 96. All right? We got a few more. Number 23. It says the domain and range. Well, domain is my X, range is my Y. Okay? X goes left to right. So here's the farthest point to the left. Here's the farthest point to the right. Okay? So the farthest point to the left is negative 5. The farthest point to the right is positive 4. It's going to be your X value. This has an open circle, so it's just going to be less than. This one has a closed circle, so it's going to be less than or equal to. Okay? Range is your Y, so it goes from down to up. Okay? The farthest point down is this point, and it points to 0. It's a closed circle, so it's going to be less than or equal to. There's going to be a Y value, and it goes all the way up to here, which points to positive 4. Now that is an open circle, so that one's just going to be less than. And there you go. All right, number 24. It says the linear parent function f is graphed on the grid. Draw a graph that represents h of x equals negative f of x minus 2. Okay, all this means is you're taking this value, what this is, and plugging it in there, okay? Well, this is your parent function. Your parent function is y equals x. So what I'm going to do is h of x is literally this, negative x minus 2. So this is in slope-intercept form. So I can take the intercept of negative 2, and then I'm using my slope of down 1 over 1, down 1 over 1, and so on. There we go. I only need a couple points, and then I'm going to take my straight edge, which is my ID, connect the dots, and I'm going to put arrows on the ends of it. There we go. All right, and one more, 25. It says, Sam has 2 jobs. She works no more than 45 hours total at both jobs combined in 1 week. Okay, combined. Draw a graph to represent the solution set for all possible combinations of x, the number of hours worked at her first job, and y, the number of hours worked at her second job in 1 week. All right, so I have 2 jobs. So I got x and y. Okay, and oh, it even has my stuff labeled. So here's my y, here's my x. Okay, so I can work no more than 45 hours total at both of them. Okay, and let's see, this one is tricky. Represent. Okay, so that means that whatever these 2 values add up to be, they need to total 45. So if I worked 10 hours, I would have to work 35 here. If I worked 45 hours, I couldn't work at all on my second job. If I worked 20 hours, then I would need to work 25 hours total. If I worked 25 hours here, I could not work on my second job 20 hours because 25 plus 20 gives me 45. If I worked 45 hours on my second job, I could not work any hours on my first job. Now I start getting some points, and it looks like they're going to make a line. So what I'm going to do is I'm going to connect the dots. Oh, hey, there we go. I got a line. I have my graph. And there we go. All right, guys, if you have any questions, please feel free to ask me. You can also email me at efee@leisd.ws. Until next time.